Alright, so today we're going to learn 3.8. This is 3.8 from the Dolciani Algebra 2 book, and 3.8 is about functions. A function is a correspondence between sets, the domain and the range, those are the sets, that assigns each member of the domain exactly one member of the range. So you need to know what the domain and the range are. The domain everything in the domain is the x values or what you input. The range is the y values or the alphabet or output. And if you can't remember that the domain is the x values, range is the y values, think alphabetical order. X is before y in the alphabet, D is before R in the alphabet, right? So X goes with D, Y goes with R. Okay? So examples of functions. Okay, examples of functions. So I have a few examples already written down. We have all these points, -1, 7, 2, 6, 3, 6, 5, 6. Okay, and we're going to map it because when we map it, it's easier to see if it's a function or not. So let's write in the domain, which is the x values, right? We should all know points by now. So the first one, alright, so our first point is -1. That goes under our D. Okay, I'm looking at the x value, so the first number in each of these ordered pairs, 2, 3, and then 5. Okay, I have my range, which is the y values, and we have 7, 6, 6, 6, but I'm only going to write this 6 once. Okay, and then mapping, I'm going to draw an arrow, because this is a map. I'm going to draw an arrow from 1 to whatever it matches. Okay, so 1 goes with 7, 2 goes with 6, 3 also goes with 6, and 5 also goes with 6. Okay, this is an example of a function. Okay, every x value has a y value. Okay, so I wrote something below. Let me show you. The definition of a function is that each member of D is assigned one member of R. Okay, so each member of D is assigned one member of R. Yes, 2, 3, and 5 are all assigned 6, but that's okay. Okay, let's look at the other one. So -2, 3, 3, 7, -2, 6. So my domain is all the first numbers in my ordered pairs. So -2 and 3. For my range, I have 3, 7, and 6. I'm going to write it in numerical order. So 3, 6, and then 7 for my range. Okay, and when I do my mapping here, 2 goes with 3. Sorry, -2 goes with 3. Then I have 3 goes with 7. And then 2 also goes with 6. Okay, so if we look at our definition, each member of D, the domain, is assigned one member of the R. If we look at the 2 right there, okay, if we look at the 2 right here, it has 2 members of the range assigned to it. Okay, so this one is not a function. So the first one is a function, this one is not a function. So let's look at some examples. Example 2. Okay, state if the map determines a function. Okay, so we're stating if it does in fact determine a function. Okay, so let's look at, let me get a color here, yellow. Let's look at the first one. Okay, so each value of D has one value of R. Okay, so 2 goes with 1, 3 goes with 1, 4 goes with 7, 5 goes with 5. So this one is a function. Okay, this one is a function. Okay, now I look at the second one. 2 goes with 7, 2 also goes with 5. Okay, because of that right there, because 2 goes with 2 numbers in the R, okay, the D goes with 2 numbers in the R, this one is not a function. Okay, next one. Okay, I have -1 goes with 5 and 2. Automatically, right there, right, it goes with 2 values in the R. So this one is also not a function. Okay, so let's look at the last one. So 1 goes with -4, 3 goes with 3, 4 also goes with 3. Okay, because every value in the x has only one R, or every value in the domain has only one R assigned to it, this one is a function. Okay, this one is a function. So let's go down. Okay, that's it. That's how you figure out functions.